I'll start recording. If you're okay with the videos on, please feel free to keep your videos on or off. We've started the recording. Just wanted to mention that thank you all for joining the course and the summer program that we are doing, and hopefully you have learned a bit more skills than what you had done before. So hopefully you will get to know more, get to work on challenges, local challenges, especially on plastic. This year's topic is microplastic, and you have learned so far on creating story maps. You've learned working on various different data, creating different maps, layering different maps. So it's great that you've had the skill already. Now continuing with our discussion on microplastic. We have Professor Joachim Goes from Lemon Dorothy Earth Observatory, and he has been really spearheading a lot of research on microplastic at Columbia University, and he's very, very inspirational, and he's one of the people who really inspired me to learn about microplastic, see how this plastic is destroying a lot of our environmental environmental assets, and also to learn from the science behind why this is really important, and how can we investigate into looking at microplastic more carefully, and what can we do to do advocacy, to learn about it, spread the word, and which trickles down to a lot of you eco ambassadors taking up this challenge and continuing to spread the word and trying to be more sustainable. We had heard from New Jersey Sea Grant, Diana and her colleague who were there, on how we can make little changes to make our living more sustainable and to avoid plastic. So we'll continue with that conversation. And with that, I'll hand over to Professor Ghosh to share his work, and hopefully Crow, you'll be able to assist with the slides. You want to go over to the next one?
Good morning, everyone. It says my Zoom quit. Am I still on?
We can see you. We can see you, suppose. Yes.
Okay. So anyway, I titled my talk Drowning in an Ocean of Plastics. And, these are stunning photographs from some countries in Asia, which I just wanted to give you an idea about. And you'll see that the rivers, their waterways are completely full of plastics. And I won't tell you the countries where these photographs are coming from, but it's just a sign of how, and what I want to emphasize over here is that these plastics are not produced locally, okay? They come as material from the West, actually. The West has always had this idea that the plastics can be upscaled or recycled better in developing countries. And, locally in those countries, it generates employment. But the whole thing now is that their systems, which in the past were able to handle the volume of plastics coming, are no longer sustainable. And so you see all these plastics that come from different parts of the world, especially the West, end up on their shorelines, and it's unmanaged, and it ends up in their waterways. So here are some pictures that you'll see what is the state of plastic pollution in some of these countries. Can I have the next slide, please? Yes, so on average, we produce about 270 million tons of plastics per year. And this is just a conservative estimate. the current estimates based on more reliable data show that we produce about 400 million tons of plastics per year. And almost about 100% actually ends up in as plastic waste. Most of it is single-use plastics that ends up, in landfill sites, many of which are in poor neighborhoods and in localities very close to the shoreline. And the previous pictures that I showed you, my opening slide also showed you a picture where you can see a mother and her child rummaging through plastics. And you can see that because this is unsustainable in those countries, most of it is dumped along the shorelines, hoping that the tides or the rising sea might just take it away and go away with it. But what you see visually is not what is the problem. What is the problem is what we cannot see. These plastic pieces end up becoming, because of the sun rays, because of bacterial action, they become tiny little plastics, okay? And these are called microplastics that are less than 5 centimeters in size. And they have a huge impact on the food chain. Can I have the next slide, please? And so, this is from a source, Jembeck et al. In 2015. And this unmanaged plastics, two of the most offending countries actually are China and India, and to a certain extent, Indonesia and some other countries in that region in Southeast Asia. But you see that by 2025, we anticipate that this plastic problem is going to get even worse. Recognizing this, the United Nations is now crafting a treaty in 2025. It is going to be signed, and already about over 100 countries have signed on to the preliminary draft. And by 2025, it is an effort led by the United States, actually, that is going to halt in some way the use of single-use plastics. And then it is also going to prevent the export of plastic waste from richer nations to poorer nations. And this is really good in a way because it is going to stimulate research on innovative ways of managing plastics within your own country. Like here in New York City, this tiny island of Manhattan produces about 1/10 of the plastics that we consume in the United States. And none of it stays within New York City. About 80% goes to New Jersey and another 20% goes to Pennsylvania. And these plastics actually go to landfills where mostly poor people reside. So it's a question of environmental justice, and it's a question of us as individuals living in these rich states or rich countries to realize that we are causing a huge, huge problem to the rest of the world. Can I have the next slide? So this is, in 2015, there was census of the plastic input into the oceans, and it shows that the inputs of plastics into the oceans are greatest in Asia. And as I want to remind you again, that these plastics are not produced within Asia. All the computers that we use, which are outdated, the phones, the plastic bags that we use in our grocery stores, all end up in these Asian countries. As I said, that it has become an unsustainable way of managing plastics in those countries. So they end up on the shoreline, and you see that these countries are blamed for 86% of the plastics that enters into the ocean. Can I have the next slide? So y'all might have heard about this, the ocean patch of plastic, the garbage patch. And I was at sea recently, and I was in the Bay of Bengal. And there too, I saw huge amounts of plastic floating on the water. But the plastics get trapped in these gyres, and you can see most of the ocean gyres have got these large plastic patches floating around. And one of the biggest patches is in the North Pacific gyre. And can I have the next slide? You can see what they look at the surface. And as I would like to state again, this is plastics are, these large plastics are a huge problem for larger animals. And when I tell you the scale of these patches, it is unimaginable. One plastic bag patch can be the size of the state of New York. So you can imagine how much impact these plastics have on our ocean ecosystem. Can I have the next slide? The problem with these plastics is that they take a long time to break down. Okay? Initially, they break down really rapidly under the impact of UV light from the sun. They become brittle. But there is a certain point at which they do not break down, and it takes about 20 to 25 years before then they can actually break down and become small particles and settle down. Can I have the next slide? So you all might have seen many, many pictures like this of plastics, animals being trapped in plastic nets. Here you can see on the side a turtle that is completely deformed because someone threw plastic, the six-pack, into the water somewhere. And you can see the seagull also wrapped in plastics that are used to hold a six-pack. You can see the turtle eating plastic. So there are many, many pictures. If you go and scour on the internet, you'll see many, many pictures like this showing the ill effects of plastics. Can I have the next slide? So I'll give you a little bit of the history of plastics. The first plastics, they were made in 1907 by this person who lived in actually New York, in Washington Heights. And this Leo Bakeland, as a young kid, used to work in his father's pharmacy. His father was a chemist, and he had a little shop at home, a little laboratory at home. And Leo used to go into his father's office, and he used to mix chemicals to see the reaction. And one day, he came across this phenol, which was used at that time to clean floors. And he mixed it with formaldehyde, which was another disinfectant. And he found out that it produced something that was really solid. And he was so excited about it because he could mold it in any shape and size. And he called it the material of 1,000 uses. And in fact, this discovery led to one of the greatest transformations in the way we use plastics. Okay, can I have the next slide? And so in the United States, it spun a huge, huge revolution. The plastic industry started flourishing. One of his biggest achievements is that in the past, the US Navy had no insulation for their wiring on the ships. So there would be many, many accidents where sailors would get electrocuted. And so this plastic was used as an insulant for this wiring on the ships. And he got huge contracts from the Navy, got lots of money. And then he started this industry where it was being used in radios, women's stockings, Tupperware, these plastic containers that became a revolution for storage of food and other items. Can I have the next slide? And then in 1939, actually, Leo Bakelite sold his company to Union Carbide. And he was appointed a professor at Columbia University. In the meantime, Union Carbide started developing additional products from in the 1960s, and some of the biggest products that they developed were these wrappers for chocolates. At that time, it was a huge improvement over the paper that they were using in the past. They started molding this into different containers. It was used for jewelry. It was used, women who couldn't afford real jewelry could use plastic jewelry. And so it became such an important part of everyone's life, stockings, for instance. And so there were several good things that came out of plastic. It made life a lot affordable for many people. And even today, if it weren't for plastics, our cars, our smartphones, everything that we use would be at least about 10 to 15 times higher than what it is today. It's only because of plastics that we are able to afford many of the products that we use. So they're good sizes to plastics. But the next slide, please. And this is one of the things in the 60s, we started using plastic bags. Okay, people were using it for shopping. And in the 70s, we had these PET bottles that replaced glass bottles. Many of these things happened before people were born. So you might have not even seen glass bottles in which your soda used to be sold. People used to use paper bags or cloth bags. So it transformed the way people live. But with this came a lot of destruction also. Can I have the next slide, please? So the thing about plastics is that, as I said, most of it at a certain point are non-biodegradable. And it has a huge impact on the life in the sea and on land as well. But today I'm focusing just on the sea. The thing about plastics is that they're made from petroleum, and it is a fossil fuel that comes from below the surface of the earth. So this petroleum is pumped from deep, either at sea or on land. And this glycol, can I have the next slide, please? This petroleum is the basis for all the plastics that we use. So the crude oil that comes into refineries, and there are several actually around our area. In New Jersey, we have about 2 or 3 plants that actually take this crude oil and then they produce this polyethylene. And this polyethylene and ethylene are then used to make this plastic product. Can I have the next slide? And if you see plastics, it is a chain of different monomers and polymers that form the basis of all the plastics that we use today. And these plastics are really difficult to break down, and so they end up in the environment. And my first encounter with plastics at sea was in 2016. Can I have the next slide? When we started seeing all these plastic particles around the Korean Peninsula. And we realized then that these plastics, we did some back trajectory analysis, a tool that you can use to find out where these particles were coming from. And we found out that they were coming mostly from cosmetic industries in South Korea. And but this is not the only things. So these plastic beads are used in cosmetics, and they're used as abrasive for cleaning your skin and making it smoother. Can I have the next slide, please? And then you see this other kinds of plastics. They exist not only in the form of beads, they exist in the form of fibers and fragments. And if I tell you today, the largest source, can I have the next slide, of plastics in our environment actually is these fibers and these unusual shaped plastic particles. And the thing about these plastics is that they attract pollutants that enter our waterways. And in a study done in our lab, we were able to see in New York City, these plastics served as a surface by which all the pharmaceutical products would get absorbed onto. So plastics are non-polar in the sense they repel water, but they attract non-polar compounds as well. So non-polar compounds like pharmaceuticals and then PCBs, pesticides of all sorts, even heavy metals and all, adsorb onto these plastics. And these plastics, as I will show you in a few slides later, end up in our seafood. So indirectly, we are harming ourselves through the ingestion of plastics and the pollutants that adsorb onto them into our food system. Can I have the next slide, please? So these are studies all done by students like you in our lab. And this is a study done by a student by the name of Crystal from a high school in Staten Island. I think it was called the Harvard School. And she started looking at oysters from the Billion Oyster Project which is in New York City. And she got some samples from them. And she told me when she looked at the samples under the microscope, it was like a forest in the guts of these oysters, forest of plastics. And she saw them come in different shapes and sizes. And mostly what she said she saw were fibers. So can I have the next slide? And when she said that, one of the things that we did, the next batch of students that came, we started trying to find out what these plastics were. And by which time we came to know that most of these plastics fibers that she was seeing, we had a new instrument brought into our lab, and we found out that they were mostly polyesters and different kinds of polyesters. And so we started looking at clothing, and we had a few students who actually were fortunate to come into our lab when the fashion industry started getting interested in our work. And we got hundreds of samples from different fabric makers from all around the world. And they tested these fabrics, and they found out, in this, what you see in the middle panel on top is different kinds of fabrics shedding fibers every time you wash your clothes. So they found out that there were certain fabrics like suede and then, mostly winter clothes, fabrics that were used for making winter clothes that shed a lot of fibers into the water. And they found out that on average, every time you wash your clothes, you lose about 1.5% of the weight of the clothes, the mass of the clothes during the washing process, and you lose another 1.5% when you dry your clothes. So what is washed in the washing machine actually ends up in the sewer system, and it finds its way into the ocean. The other component is when you're drying your clothes, you can see that a lot of these fibers end up in the air. So today, I can guarantee you, every time you look under your bed or behind your computer, for instance, if you're using a computer at home, or you just brush your finger over, your floor, you'll find some dust. And if you look at this dust under the microscope, most of it is actually fibers, and it is fibers from our clothing. And these fibers are killing us slowly. And I cannot emphasize enough that this study on plastics is really recent. It has picked up only in the past 6 or 7 years. But the more recent studies are showing that these plastics are having a huge impact on human health. Can I have the next slide, please? And so what you see over here is students who dissected some shrimp. This was the first batch of students from a school in, I think so they were from Brooklyn, the Uncommon Charter School System. And they examined shrimp from different countries. And they found, these plastic fibers, plastic pieces in the shrimp. And this immediately alerted us to the fact that many, many people consume seafood. We have barely touched the surface of the seafood. but all of them contain plastic now. And this is plastics actually that is coming out from the breakdown of large plastic particles or just the release of plastics from our laundering of clothes. So every time you buy your clothes now, I want you all to think very carefully whether I really need that piece of clothing. Can I do with it for another few months? Can I recycle my clothing? Think of innovative ways where you can prevent the fibers from getting into our system. So wash your clothes less regularly and so forth. But another big source of microplastics is the detergents that we use. Today, if you look at your detergents, and this is work done by students, again, they found that the detergents were full of plastics. And the reason why they use these plastics in detergents is they use them as abrasives for cleaning the clothes. Next slide, please. So, one of the things that when Obama was the president, he signed the Clean Water Act. And this was in 2015. And it eliminated the use of microbeads in all sorts of cosmetics and in any oral products like toothpaste and so forth, shampoos. But what they forgot was that detergents contained a lot of plastics. So we are working with NGO now to try and eliminate plastics from detergents as well. Next slide, please. So these detergents, you can see, are full of plastics. And our goal in the next few months is to try and work with city officials and our representatives, both at the state and the federal government level, to try and eliminate microplastics from detergents. Next slide, please. So at our lab, we have started some work where we are trying to arrest the flow of microplastics from your clothing, both from the dryer and the washer. And our lab is actively involved in trying to develop methods to stop plastics from coming into the ocean or into your waterways. Next slide, please. And some of you who have visited our lab must have seen the system. We have built a very complex filtration system that is now being used. It's a prototype. It looks big. It's as tall as one of you. But our hope is that we can miniaturize this and incorporate it into the washing machines and the dryers that we have in the market today. Next slide, please. So what can we do to reduce the amount of plastic waste that ends up in the ocean? One of the things that you should do is to refuse plastic that are single use. Try and carry your own utensils, for instance. So that way you reduce the amount of plastics that you use personally. Try and reuse plastics if you really have to use them, because I do know that as kids, plastics are easy to handle. And so make an attempt to try and reuse as much as you can, and then help with the recycling process in your communities. And overall, you have to redesign your lifestyle. Can I have the next slide, please? Yeah. So how can you help the oceans is use fewer plastic products, take part in community activities like cleaning the beach and cleaning your neighborhood, and try and use eco-friendly products. So I think that's my last slide. But I want to tell you that we have a lot of high school students who are working in our lab, and most of this work that I've showcased today was done mostly by students like you who are concerned about plastics. And one of the students who came to our lab at the age of 14 is still here with us today. His name is Ishan. He's from New Jersey. And this year he's working on trying to use the saliva of worms to break down plastics. And we're also working on some geoengineered bacteria which we are hoping can break down plastics as well. So these are student-led projects, and we welcome students to come to our lab. But the only thing is that you have to let us know well in advance, because we get hundreds of applications, and obviously we cannot accommodate everyone because of limitations on space. But I urge you to look at the Lamont high school program and try and join the efforts being done here to reduce plastic usage and reuse the plastics. Thank you.
Thank you so much, Professor Ghosh. This was really very helpful to see the science behind it, also to see where these actions are and what is your lab doing specifically to tackle this particular problem. And it is a really great to see how students have come up with working with you on the lab and learning all the science protocols to understand how we can take this particular problem and understand the massive impacts of microplastic here. So really thank you to to really give us a scope of where things are. How can we, as high school students, most of you are joining here, how can the high school students and middle school students take this particular challenge on? So maybe we can take one or two questions, and we also have another presenter, and we'll save the other questions towards the end of the session. One or two questions for Professor Ghosh. Looks like everyone is liking the presentation quite a bit. Yes, Bernice?
Yeah, thank you so much for being able to give this talk. It's very informative, and I learned a lot, especially through when you exhibit the different projects that the high schoolers did. So one of your slide was about the fashion to fashion circular economy machine. Can you talk more about it? It seems very interesting, and I would just love to learn more and how it operates.
Yeah. So we have tried to work with the fashion industry because there's some awareness in that industry that their products are actually causing great harm to the environment, especially to the oceanic environment. And even on land, as I said, most of the air we breathe today contains a lot of microplastic fibers. And so our work over here is to try and degrade most of this material that is used in the fashion industry. Most of it is based out of polyester. If you go to some countries like India, you see you have different kinds of saris. Some are made of cotton, some are made of nylon, and some other polyester material. And mostly it's the working class, that needs to wash their saris immediately and get it dried for the next day. These people use synthetic material. And many people who have jobs that provide them with very little time to actually wash cotton clothes, for instance, they rely on synthetic products. The problem is, again, every time you wash your clothes, you have this huge amount of microplastics that come into the ocean. Can you imagine a city like New York? We have about 12 million people who reside over here. And if they wash their clothes once a week, we have almost about 2 million tons of microplastics that enters our waterways every week. In Mumbai, for instance, 25 to 28 million people living there. And you can imagine how much of plastics come into the oceans. So one of the things that we are trying to do is to work with these wastewater treatment plants also, apart from the companies making these laundry machines, is to try, with the laundry machines, we are developing this filtration system to arrest the plastics at the source. But with other industries, like the wastewater treatment plants, we are working with them to try and take the sludge that they collect and try and upscale it or try and break down those products. And you can break those products in different ways. You can just take it to a landfill, and the current practice is to just burn it. But every time you burn polyesters, they produce harmful gases that are toxic to human beings. What we are trying to do here is to develop biological ways of degrading this, more user eco-friendly methods. So we are trying different kinds of enzymes. We are trying different kinds of chemicals that are not toxic to the environment, and trying to convert these polymers that you have that are used in clothing to monomers, which can then be recycled. So this is one way we are trying to do this. And the second way, with the fashion industry, they are now aware of the damage that their clothing is causing, and many retailers are now trying to provide special space in their retail shops for clothes that are recycled. So it's not become popular over here, but in some countries like Japan, you can go to a store and can buy recycled clothing, which is as good as new. So the fashion industry is taking some steps, but we on our part have to also try and find some solutions to the problem that we're having today.
Okay, Professor Ghosh. Ale, can you hold on to your question for a bit? Because we also have Aryan Jain, who has actually worked in Professor Ghosh's lab. And I wanted him to share his experience while working at the lab and the things that he learned from his experience. Aryan, over to you. He's an eco ambassador in Melbourne and has been spearheading a lot of initiatives in Melbourne, doing native plants, focusing on avoiding single-use plastic bans while he was still very young in the elementary school, and in our community library, he was able to share some of his presentations. So over to you, Aryan, on what are the lessons that you learned at Professor Ghosh's lab, and what are your reflections?
Well, hello everyone. Thank you for letting me present today, Dr. Younger. I will be talking about the procedure at the lab and my takeaways, the impact that had on me. Now, can everyone see my presentation?
Not yes, we can.
Right, okay. So yes, I visited the Lamont Doherty lab for microplastics research. And I'll just be talking about the procedure we did in general, the steps we took to find microplastics in our samples. So we tested two different types of samples. We tested clothing, laundry, and shrimp for microplastics. Now we used both farm-grown and wild shrimp, many different types of samples of each. The reason we use shrimp is because that's a very common seafood for humans, and it represents an important middle point in the food chain. So it's a good indicator when looking at plastic pollution and plastic contamination in our food supply. So the safety protocols which we use before testing for microplastics were to wear a lab coat, protect our hands with gloves, keep our lab space clear and organized, handling the instruments with care, listening to our lab supervisor, which was in this case Dr. Ghosh, and carefully following the lab protocol. So we first had to, right, this is a procedure for finding microplastics. Now we extracted microplastics from shrimp in two different cases, involving soft tissue and involving organs. In this case, we would hold it with our hands and use a dissection and use scissors to cut through dorsal segments in order to expose the soft tissue. Then we would remove a small section of the tissue and place it into a labeled glass vial. As you can see in this image, they are removing the black part. This part is the digestive system. We also remove this part. And this would hold the most microplastics because food and water would pass through it. This is involving organs. You can see it has a much tougher shell. So we would use scissors to cut through the shell, carapace, or skin, and gently cut through the organs or around the organs. We gently separated the soft tissue surrounding the organs, cut through the connective tissues so that the organs could be pulled free, and then gently pull the organs from a sample and placed into a labeled glass vial. And in the third case, we also used clothing. This is a washing machine, and we put several different types of clothing, polyester, cotton, denim, inside this washing machine. And we also put detergent inside it. All of those contain some level of microplastics. Then we washed it in this washing machine and collected the microplastics. So the steps are to place the articles of clothing in the washing machine, add detergent, or avoid detergents for control, since detergents often do have microplastics inside them as well. Place the drainage hose inside a non-plastic container. So the residue would travel from here through the drainage hose into the non-plastic container. Now, it has to be non-plastic to avoid any contamination, because if it is plastic, then that plastic will come into the sample and it'll skew the results. So to make it as accurate as possible, we use a non-plastic container and collect at least 500 milliliters of washing machine effluent. Now, we had to isolate the microplastics in the samples. So in the organic material from a shrimp and the clothing, it included lipids or fats that would also bind with the staining solution. This means that when we would put it under a microscope and look at the sample under certain types of light, the staining solution would bind to these lipids and then glow. So we would then mistake these lipids for microplastics. So we need to remove the fats or lipids from the sample before we put it under a microscope. So we use hydrogen peroxide or H2O2, which is a corrosive material. This is why we have to we handle the procedure with a lot of care so that we wouldn't harm ourselves. And we also used a vortexer. This would properly mix the H2O2 and the sample. So we put the sample inside a glass vial. Then we put the H2O2 inside this glass vial and use a vortexer to spin them. This would force microplastics, which are binded to any organic material, to be forced apart and is separated as much as possible. Afterwards, the sample must be heated to complete the reaction. Then a vacuum filtration will be used afterwards to physically separate the microplastics from the organic material in the sample. So we isolated the microplastics in two different cases. This is for samples involving animal tissue. This is for all samples, also including the laundry samples. So here we use a glass pipette and a fume hood. This is a fume hood. Let me turn on my laser pointer. This is a fume hood. So, and we would put our arm inside this and use a glass pipette to put the hydrogen peroxide in the samples. So we pipetted 2 milliliters of hydrogen peroxide into the glass vial. Then we used a vortexer to agitate the glass vial containing the tissue sample and hydrogen peroxide. And then we place the sample in the oven at 68 degrees overnight, 68 degrees Celsius. This would complete the reaction. Then we remove the glass vial from the oven and inspect the vial and contents. It should be clear at this stage. Now this is the stage we do for all samples. Following step A, we assemble a vacuum filtration apparatus. This is a vacuum filtration apparatus. It has a vacuum air pump, this thing, a vacuum hose. This hose connects this bottle to the vacuum air pump, a glass funnel. This is a glass funnel, a glass receiver, and a glass frit with a sand core filter head and a glass microfiber filter. This is this part here. So essentially what is happening is that the vacuum is pulling air through. And that means that the sample, which will be placed in this part, is also being pulled through. Now it's being pulled through this filter into this bottom bottle. So the filter, it allows lipids and hydrogen peroxide to go through, but it prevents microplastics from passing through. So it'll be pulled down and the microplastics will, in the end, rest on this layer here. So run the vacuum air pump, pour the contents of the glass vial into the glass funnel. Once the glass funnel empties, pour in 100 milliliters of Millicue ultra pure water. Now it has to be ultra pure because regular water has microplastics inside it. So it could make the results inaccurate. We use ultra pure water to avoid any contamination of the sample. Then we remove the glass microfiber filter. So this is a glass microfiber filter, and this was here at this part. And you place it onto a labeled glass slide. You can see this is shrimp farm India or shrimp number 1. So we label them so we can identify everything. Then we will place the labeled glass slide onto the glass, we'll place it into an oven at 68 degrees Celsius overnight. Now this is the staining part. So after we have heated this, we have the sample of microplastics onto these slides. We'll put a staining solution onto them so that when we look at it under the microscope, the staining solution will bind to the microplastics and it'll glow. Under certain wavelengths, it'll glow. So it'll essentially make the microplastics visible. This is also why we needed to remove the lipids, because if the staining solution binds to the lipids, then it'll cause the lipids to glow and we'll mistake those for microplastics. So we prepared a Nile red staining solution. That's the name of the staining solution, where in a glass vial, we would combine 1 milligram of Nile red powder with 10 milliliters of 90% acetone, 90% acetone and 10% water. This should result in this color of pink dye. Now we will surround a glass foil with aluminum foil. And with a small pipette, like the one we used earlier, we place drops of the Nile red staining solution onto the glass microfiber filter. We just place them on top of here. You can see that these are already pink, meaning that we had already placed the solution on top. And after we do that, we let the sample rest for several hours. Now, these are the findings. So we put these under a microscope and then analyze them. We analyze the samples under a microscope using fluorescent light, and we counted a number of plastic particles by hand, like this. We would just look at under the microscope and count each of these individual pieces. Now, plastic was found in all sources. Every single source, regardless of wild shrimp, farm-grown shrimp, or laundry, everything had microplastics. But there was more microplastics in the farm-grown shrimp than in the wild shrimp. These are because of unethical practices used by shrimp growers in countries like India, where they will actually incorporate plastic into the shrimp feed to make the shrimp feed float at the surface. It facilitates the feeding process. So they'll actually deliberately feed shrimp microplastics. And the laundry had the most plastic. This is because a certain type of clothing like polyester naturally contains a lot of plastic. Polyester is made of plastic. Laundry detergent also contains a very high concentration of plastic. Other types of clothing like cotton or denim doesn't contain as much plastic, but still contributes to the contamination. So this is the laundry sample under the microscope. Now you can see that these things are glowing. This is because the Nile red staining solution has bonded to the microplastics and is making them glow under fluorescent light. So we just counted the pieces. You can see that in the laundry sample, we have very large pieces and they're very numerous. Now, this is actually a special case. So Dr. Goes, he analyzed this eco-friendly laundry detergent. My mother actually got this. It was supposed to have no plastics inside it, be completely environmentally friendly. But we looked at it underneath the process, and we could see that even in this, there were still microplastics. As you can see here, this is the glowing part. So takeaways. Microplastics should be classified as an ambient, ubiquitous particle. That means that they are all around us in our environment. They're in our water, in our air. They're inside our bodies. They're like bacteria at this point. They're everywhere. We actually also looked at a pond sample, and inside that we could also see large concentration of microplastics. So it's impossible to completely avoid microplastics. Their presence in our food and water supply is ubiquitous. And they're also extremely present in our clothing and many everyday personal and clothing cleaning supplies, like the laundry detergent. The thing is that microplastics, as Dr. Goes said beforehand, present a very grave health concern. And while the research is still in early stages, studies show that microplastics can impede brain function and increase the risk of heart attack. So it is up to our society and our civilization to decide whether or not we want to slowly phase out microplastics. At this point, we cannot really filter them from our food and water, but if we do decide to stop using them, eventually they will no longer be around. So it is up to all of us to identify and eliminate any sources of microplastics in our daily use products. Thank you.
Aryan, thank you so much for the elaboration of your technique in the lab under Professor Ghosh. Any questions for Aryan? Any questions in general? As we see, it is not a small task to understand this menace of microplastic. It is everywhere in food, raw material, raw food supplies, in clothing. It is everywhere. So any ideas on what we can take from this research? What can we take from Professor Ghosh's presentation? Maybe one or two reflections, quick reflections. We are almost at the hour, and I want to also give Crow to just do some housekeeping and other things. Maybe one reflection from anyone. Any questions for Aryan? A lot to digest here. We will be posting this recording in our in the Google Classroom, so feel free to see it again. Yes, Ale?
Thank you. First of all, I wanted to thank you for the interesting presentation. And then I wanted to ask about, is there any effective technology or strategy for cleaning up plastic in general from ocean?
Right, should I answer it or should Dr. Ghosh answer it?
Go ahead, Aryan, you give your answer, and then I will add on to it.
Right. So at the Lamont lab, Dr. Ghosh actually showed us this very cool technology that they're developing. I think he also showed it in one of the slides. It was this long tubular structure where at the top he would put in a regular laundry sample, and it would go through an intensive filtering and cleaning process until at the end, regular water was left, pure water. So as he said, they are planning on making a more portable type of structure. As for collecting microplastics from the ocean or from other sources, I'm not aware of any such technology that can effectively do that because it is so small, but maybe Dr. Ghosh knows of that.
Yes, so we have just got a recent award from NOAA, actually, to develop a device that will use artificial intelligence to pick up large plastic particles from the ocean. And this grant will start by the end of this year. So we'll be working with computer scientists to identify plastics, discriminate them from wood and other debris floating in the water. And this is, again, only for large plastics. What we are doing for microplastics is trying to arrest them at the source. This is also a project funded by NOAA. But there are some technologies emerging for trying to get rid of microplastics in waterways. And these are called hydrogels. There's organic colloids, which are bound to metals. And these hydrogels have got a high propensity for attracting plastic particles. And so it is being promoted aggressively in different parts of the world now. These hydrogels are microscopic. You just drop them in the water, and hopefully they'll attract all the plastic particles and settle to the bottom. The secondary effects of this are not known, what it will do to the ocean bed, but this is a technology that people are pursuing. There's no way we can filter the entire ocean. It's just beyond something that's conceivable. But things like hydrogels, like in small water bodies that are used for drinking water, in developing countries can be a useful way to tackle the problem.
Thank you so much, Professor Ghosh. Thank you, Aryan. With that, I think we will, unfortunately, we are over time and we will not be taking more questions, but feel free to keep discussing amongst yourselves and also through the Google Classroom post comments so that we can keep engaging on this really important topic. Over to Crow for any housekeeping, any announcements on your end, Crow?
Yeah, thank you to both of you for those amazing presentations. On Thursday, same time, 9 a.m. Eastern Standard Time, we are going to have office hours for anyone who has questions about their story maps. There is a Google form on the Google Classroom. Please fill that out by today if you want to attend the office hours. That just has your name and any questions. If you don't fill out the form, we can't send you the Zoom meeting link for the office hours.
Thank you, Crow. And the next class will be on Wednesday, 31st July, which will be again at the same time. And we'll again be going over a lot of, microplastic related research, as well as, I think on the 31st, we have detecting plastic waste sites using satellite imagery and crowdsource data, which will be again very fascinating. We've seen micro related work on like really dissecting where is microplastic, but now we'll look at like a crowdsource data and we'll look at satellite imagery to see how we can detect plastic waste on Earth, and maybe you can use it to detect plastic waste near your locations. It's really important to make it your own and see how you can use all these skills to learn about your own neighborhood and learn from this particular technology. Great. Nothing else from your side, Crow, right?
Nope, that's all from me.
Great. Thank you so much. And please remember to fill in the link that Crow mentioned for if you want to be participating in the office hours. It is not mandatory. Only if you have questions, definitely let us know. Thank you so much. Take care.
Bye.
Thanks for joining us today. Thank you.
Thank
Professor.
you.
Thanks, Ariel. Thank you.
Bye. Thank
Bye.
you. Bye.